Okay.
Oh, darling, we just have to join this together because what you didn't see is CJ's arms are aching because he's holding the camera. Yeah, so we just got a slight break, but we're carrying on. Anyway, let's carry on.
Okay. Next question is, what are settings for generators, wind turbines? Specifically asked as well as which ports they need to use.
Right, okay, so if you're using, there's two different ways, you asked two different questions.
Yes, sorry,
So
it's
a generator would be connected to the auxiliary port and you select it as generator and you select the settings accordingly and you have to tell the generator when to use. So if you just connect a generator into the port, it won't do anything. You put it on and say, oh, it won't charge a thing. You have to tell it to charge the generator. You do it from the systems controller. So you have to tell it to charge. If you don't tell it to charge, it won't do. So you would actually go, you have to select gen charge, gen signal. If you've got an ATS on the generator, the ATS, the automatic transfer switch, that will switch the generator on and the generator will start running. And we actually have, no, it's not to do with the switch, it's not to do with the first point. The ATS is part of a generator. So it's called the automatic transfer switch. And that basically, when it gets the signal, it will switch the generator on, it will start up, and then it will pull the power from the generator. Wire the generator two ways. You can wire the generator into the grid port, which means you can use a smaller generator. Don't forget to put the CT coil on the grid port. If you put it on the grid port, you must put the CT coil. Because otherwise it could back export back into the generator and you'll end of generator. If you connect the generator into the auxiliary port, you have to know that that generator is powerful enough to supply the full load and charge the batteries at the same time. And if you've got a, if you've got an 8 kVA inverter, then you probably need something like a 12 or a 15 kVA generator. Otherwise, as soon as that generator really closes, the generator will slow down, and you're going to get, the frequency is going to go out, it's going to drop out, so it'll break the connection, and then it will disconnect, and then it's going to cycle it, keep trying it, keep cycling, and you got a problem. Wind turbines are a different thing. Okay, so wind turbine, you've got a wind turbine, which is a, often wind turbine uses what they call a PM, permanent magnet. Magnet goes across three coils, generates the power, comes in three phase. You have to then put it through a three-phase rectifier, and then using some sort of a limiting resistor and what we call a pipe filter, a couple of capacitors, and then providing it matches, the wind turbine has got the correct voltages, so you look at 200 volt turbine and stuff, then you can import it directly onto the MPPT. However, there are other ways of doing it, and we've actually got an interesting thing which we'll put up very soon, a little box of tricks that you can connect the wind turbine into the auxiliary, and it can take it straight to the auxiliary port, and rather than using it onto one of the MPPTs. That way it will free the MPPTs up, and this little box of tricks that we've got, the wind turbine converter box, which will be available very, very soon, and we might include a couple of relatively low cost. I'm not a big mechanical stuff, is not me, and I'm petrified of mechanical things, so I'm really, really nervous of mechanical things. But you could use this box of tricks, and this will give you a separate profiling, because obviously, you understand when a wind turbine, you can't have the thing too stiff, because the wind will never blow it, and the stiffness is caused by the loading, so you have it very light and very easy to go round, and as it starts to get momentum, starts to get speed, then you load the turbine. And so as it goes faster, it increases the voltage, and the voltage increases and you increase your load, and that's your profile, and that's it, you set your profile. And whether you can do the profile on the inverter, or you can do the profile on the converter box, which will be available soon. So you've got the choice, you can do either way. But anyway, there's loads and loads of stuff on using a generator. I've got a whole section using a generator. So please have a look at that separate video.
Okay. Another question we get asked quite a lot is where to plug in the neutral, the live wires.
Okay. All right. If you're unsure where to connect the wires, then get an electrician. Basically, the grid connection is both input and output. It's an input. You don't go, oh, the grid is the in and the load is the out. Absolutely not correct. The grid is both in and out AC coupled. The load is a UPS, and the auxiliary is wherever you want it to be. If you're unsure between the live and the neutral wires, please, you're not qualified, don't touch it, get an electrician, because I do be funny. If you've got that uncertainty, get some advice, because you're going to kill yourself. So absolutely, please, if that question comes up, and somebody asks me that question, go and seek advice. The thing, but the only thing some people do get confused about is understanding the difference between the load connection and the grid connection. They are separate functions, they're completely separate functions. The load connection is a UPS, and the other thing is, don't forget, when you use the load connection as UPS, as per previous video, then that outputs as a class 2. If you need to make it to a class 1, which you will do for most applications, and you need to create an earth neutral bond, please look at previous video showing about earth neutral bonds.
Lovely. Okay. Next question. What are essential loads and how to set up what loads per inverter side, i.e. are 3.6 or 5.5 or 8 or 10 or
Okay.
12, the even bigger monster that's out at the moment?
So essential loads is when you connect to an inverter, if you're on grid, you've got a grid supply, then your inverter can be much smaller than your demand. So if you've got a 16 amp inverter and your demand is 100, your peak demand is 100 amp, then your non-essential loads you will connect on the grid side. You still get the benefit because the sun will shine, and you can still get benefit on the grid side because it works both ways. CT coil prevent the export, so you can use the power from the solar or the battery on the grid side. The other side is the load side, which is essential loads. What would you connect? Well, basically, you connect what you think is important. If you're gonna suffer power outages or power outages or whatever, then you would connect what you think. I would probably suggest your lighting, maybe depending on the size of your inverter, maybe one aircon, fans, refrigerators, PCs, stuff like that. What you're not going to connect on your essential loads is your hot water geysers and massive air conditioning units. You don't want to do that because, quite honestly, you don't want to flatten the battery. So you want to be able to put on it what you need in case of a power outage, what are the minimum requirements you need to keep comfortable and safe and secure. So, of course, your security systems is an essential load. So what you consider is essential, certainly your lighting is essential. If you're wiring in essential loads, you need a separate consumer unit, a separate fuse box. And I would also recommend put a bypass switch. So basically, if you come to service the inverter, then you need to bypass it, because otherwise, if you come to service the inverter and the inverter switched off, then you're going to lose your essential loads. So you need to wire a bypass switch, separate consumer unit. And again, I might do a separate video and explaining a little bit more about that.
Please.
But, okay, but it is simple. It is straightforward. So.
Okay. Next question is, my battery is not charging. That's a common one that we get majority of the time.
Right, okay. So for the battery to charge, you have to tell it to charge. Because if you just connect it up as default, then default it mightn't function. You have to decide. First of all, a lot of people will you have to set your battery settings correctly. So when you install it, make sure you've got your battery comms is working. So I've got all battery comms, all my parameters are set. My maximum charge current is you set on your battery parameter setting. And then if you're presuming you're going to charge the batteries from the solar panel, you go on your system mode controller, and you might choose not to export, put the power in. You set the level on your controller, and the level will be the level of the discharge. So for example, if you set that level at 20%, means that battery will go to 20%. If you're using the power for something else, then you'll never charge the battery. It will stay at 20%. If you set that level to say 50, 60, 70%, then the battery will start, and you're prioritizing to the battery, and then that will start charging the battery automatically. You've got to make sure. Again, we're making it really easy on the app. So it's a single button programming. And if you use the new app, there are some recommended settings. And I'm going to ask Joel, who's not on this video, to try to list some of the more easier ones, and it make it much easier to do that. But first of all, when you install, make sure you've got communication. If you haven't got communication on your battery and there's a problem with the comms, then you're going to get all sorts of problems. You're going to get faults coming, you're going to get, if you're in parallel, you're going to get parallel faults. Everything is caused. The most important thing right at the beginning when you're installing it, even if it's one inverter or a parallel inverter, please make sure you've actually got comms from the battery to the, and you can check that. A cog in the bottom top corner goes onto the navigation page. Bottom right, lithium ion. I'm sure everyone knows it, and you'll see the screen. If it's a load of numbers, meaningless, then you haven't got it. If you've suddenly got very clear telling you the battery rating, everything else, state of charge, everything else is very clear, then you've got comms. That's really important to check that.
This leads into the next question, actually, which you may have covered previously. How to make sure an inverter charges at specific times. People are not familiar with the settings.
Again, it's the system mode controller. It says you go onto the controller, so the system mode controller. You actually say what point. So you can choose two things. First of all, if you want to charge the battery from a particular time at night time, then you say, you select the time, and you say grid charge or generator. If you're running a generator, you click the button, you click that button, and you tell it the level. You may say, I want it to 100% charge at that point, and it will charge the battery. You then have to say later on, I want it to discharge the battery, so then you set it on the profile on the controller. Again, we're going to have sort of standard formats that people can do it, but always throws little people on that. But it's really simple, because it says when you want to start charging, when you want to stop charging. It's you see on the system controller. So the system controller, off the navigation page, top right hand button. Well, people do get a little bit confused on it, but we made it much easier to use the controller. You have to use the controller. You have to tick, please use timer, and the timer is little bit like a central heating timer, or your timer to work whatever. It needs, you've got to set it. And don't do what I did once. I forgot to set the time of the inverter. It will pull it off the internet, but if it doesn't pull off the internet, then if for some reason you haven't set data logger on it, then please make sure you set the time on it, because otherwise your timer won't work properly. And that's a simple mistake made by even myself one time. So, and I think it's on one of the videos.
Okay. How to set up load shredding.
Load
shredding.
Load shredding. No, it's not load shredding.
Load
shaving. Okay, that's a South Africa tip for power outage.
It does mainly come from South Africa.
Yes. No, it's not called load shredding. Okay, so basically, you would set the inverter up as a UPS. So basically, as a UPS. So you want to have the maximum charge on the battery. We're going to add a new feature actually. We were talking about adding something on the app today, which is a force charge button on the home screen of the app. And you press that button, and it will force charge. But a lot of it will be just simple down. That's exactly what you're talking about. Your essential loads, your non-essential loads. In this case, you want to make sure the battery is fully charged, because your battery, it's for a different reason, because some people, for example, using the battery to save money. Some people use the battery as security. And if you're in an environment where you've got load shaving, then you would actually want the battery as security. So you want to try and keep the battery relatively charged, and the excess power then you can use or whatever. Or you might have a big enough battery you can cycle some of it. But that's just down to your essential loads and your non-essential loads.
Okay. Only two more, CJ. How's your arms?
Yeah, we're getting there.
How to run two inverters if not parallel, i.e. one runs a PV and the other one obviously runs the loads from the house?
You can do that. And in fact, I actually done something in Holland where we're using two separate inverters, and it got a little bit more complicated, but we tried to be clever, and in fact the system's working great. You can use one inverter as a dedicated charger, and it will charge the batteries, and you can use the other as an output. The benefit of doing it that way is if you have power outages, there is no drop the power, because it's constantly fed off one inverter all the time, and the other one is constantly charging. If you lose power, then there's zero interruptions, zero changeover, because sometimes, even though we have a changeover on the cycle, you've got that little bit of click, and it causes a slight spike. On this way, there is nothing. It's just completely seamless. So basically, you use the batteries as the common. So one is charging the batteries, one is discharging the batteries. The only time you would ever use that, if you were going to, for example, if you're, I don't know, mining bitcoins or something like that, and you've got very delicate equipment, our products shouldn't affect it, because we actually switch over within the frequency. But if there was a minor issue, then you could, it's very, very critical on the mains, then you would do that. But normally you wouldn't need to do that. Our inverter is a bidirectional inverter, and so therefore it can charge. The changeover is very, very fast. So it's a very rare occurrence you'd actually need to do it, but you can do it. The only reason we did it in Holland is because we were converting a single phase to a three-phase power. So we had a single phase coming in and a three-phase going out, and that way we had to do that. Well, there was no other way around it, because and not many inverters can convert single to three-phase with perfect phase rotation, and the output can be imbalanced load.
Okay, this one is quite a lot. We get asked this question. How much solar array to what size inverter?
Okay, so basically, all the inverters are rated. The 3.6 can take a 7 kilowatt of solar array. be aware it's split between the two MPPTs. MPPT is maximum peak power tracker. So basically, we're using the tracker as a DC to DC converter, and it allows the panels to work at its maximum. But I explain many times the reason for MPPT is because a very simple one, which is one I always try and explain to people. If you've got a 100-watt panel, and the 100-watt panel's a 24-volt 100-watt panel, and that would give you 4 amps. If I then connect that 100-watt panel onto a 12-volt battery, it will charge the 12-volt battery, and it will still charge at 4 amps, but now the 100-watt panel becomes a 48-watt panel. Suddenly, it's one of those magic tricks, we've lost half the power of the panel. And so the tracker, the MPPT, is DC to DC and takes it from the higher to lower. So bear in mind, you have these circuits which are DC to DC converters. They're basically, they're called a buck converter or a boost, depending on how the operation is. They normally on an inverter they're a buck converter, and so you have a limited power because they are actually similar to a little inverter themselves, and so therefore if you're on a 3.6 you've got 7 kilowatts across. On a 5 is actually about 6.5 kilowatt. On our 8.8 is about 10 kilowatt. So it goes up. Our 12 is about 15 kilowatt. All of these are covered in data sheets. They're all in the data sheets. Always bear in mind we need to consider is the maximum voltage. Okay, they're called VOC, voltage open circuit of the panel. Do not exceed the rated current, otherwise you will damage the DC to DC converter. So don't look at the MPPT voltages of the panels. Get your multimeter before you physically connect it. Look at your voltage. Most of the inverters you want to be below, I always say 450 volts is loads. Measure it, look at 400, be careful, obviously be very careful, measure your 450 volts and then connect it. If you're measuring 550, 600, it won't work, you're going to get a voltage error.
Okay, that's all our questions. Thank you very much, Keith.
So this is our first question answer, and we want to do this we'll do another one of these.
Basis.
Yeah, we'll do another one of these. I hope these are useful. She's trying to trick me, and CJ is behind the camera, still not saying very much, and I'll get him on the camera next time. So thanks for watching.
Thank you very much.
Oh, and don't forget to subscribe to our channel, please.
Yes.
Thank you.
Click the like button too.
Okay. Bye.
Bye.